Hello everyone, this is Jay from BTYT Tech Library. Today we are going to solve LeetCode problem number 47, Permutations 2. We are going to solve this problem using Heap's algorithm. It generates its permutation from the previous one by interchanging a single pair of elements. In this way, it minimizes the movement. In 1977, an American computer scientist, Robert Sedgwick, reviewed it as the most effective algorithm for generating permutations by computer. Today, we are going to briefly check on what Heap's algorithm is and focus more on the implementation aspect of it. Using the divide and conquer technique, Heap's algorithm generates all possible permutations for a given sequence of n items, by first fixing the final item and then systematically rearranging the remaining elements, repeatedly swapping the fixed item with others from the group being permuted. Heap's algorithm is simple but quite tricky. So to better understand how it works, let's dive into the examples. Heap's algorithm works slightly differently depending on the parity of the number of elements operated on at each step. For example, if the number of elements is odd, new elements in the last position. Rotate from right to left, fix the last position. And current last element to last turn. Swap first and last position. And again, new element in the last position. Rotate from right to left, fix the last position. Current last element last turn. Swap first and last position. Again, new elements in the last position. Rotate from right to left, fix the last position. Otherwise, if the number of elements is even, new elements in the last position. Move the first element to right ahead of the last position. Rotate between left to right and place to head. Fix the last position. Current last element last turn. Swap first and last position. New elements in the last position. Move the first elements to right ahead of the last position. Rotate between left to right and place to head. Fix the last position. Current last elements last turn. Swap second and last position. New elements in the last position. Move the first element to right ahead of the last position. Rotate between left to right and place to head. Fix the last position. Current last element last turn. Swap third and last position. New elements in the last position. Move the first element to right ahead of the last position. Rotate between left to right and place to head. Fix the last position. And look, sequence of the ABC examples is in the sequence of ABCD example. Heap's algorithm weaves all possible permutations with needles of iterations and threads of operation choices based on the parity of the number of elements. For effective implementation of divide and conquer technique, we are going to choose recursive approach. Like a self-reflection mirror, a recursive function is a function that references itself, and through that, it can form iteration. Now, let's get down to the code. Kotlin supports local functions, which are functions inside other functions. A local function can access local variables of outer functions. In this case, nums can be a local variable. When you write the recursive function, there are 2 points to be careful of. The first one is that you need to write exit logic to keep from an infinite loop. Obviously, for swapping, we need more than one element. Well, here's the tricky part. Recursively, Heap's algorithm fixes the last element and generates all possible permutations, with the rest of the element in place, and then swaps the last one with one of the rest and repeats. The choice of candidates for swapping depends on the parity of the number of elements. If it is even, the final element is iteratively exchanged with each element's index. Otherwise, the final element is always exchanged with the first. If you remember my metaphor, a recursive function is like a self-reflection mirror. A single mirror can reflect itself. It needs another mirror to start reflecting. I mean, quite a few people forget to trigger the recursive function after they finish the implementation. That was the second point to be careful of when you introduce a recursive function. Let's call it and let's run the test. When we run the test, it fails. Don't worry, there is a saying, failure is the mother of success. The reason is that problem requests us to return all possible unique permutations. And the good thing is that Heap's algorithm swapping operates based on the element's position. So it generates all possible permutations regardless of whether the elements consist of characters, numbers, or are unique or not. So to remove duplicates, we just need to select the right data structure, a set. Let's run the code. That's it. I think Heap's algorithm is elegant. It is concise and effective, but it still achieves the goal of generating all possible permutations.